All that data from Barrow comes here to the Earth Systems Research Laboratory in Boulder, Colorado, where that data is analyzed and shared with the rest of the research community. Air samples from around the world end up in this laboratory. The air is compared to a baseline sample, then greenhouse gases are removed and measured. The results are studied here and just down the road at the National Center for Atmospheric Research. What are greenhouse gases and what do they do?
Well, the main one that we talk about is carbon dioxide, and any gas that has more than 2 atoms to the molecule, so CO2 is carbon dioxide, H2O, water vapor, and methane, CH4. All of those are greenhouse gases, and they interfere with the outgoing radiation that would normally escape to space, and they provide a blanket for the planet. So they're heat-trapping gases in that regard.
Heat-trapping gases, creating a blanket for the planet. It's how the term global warming was born. We started with this as global warming, and then it transformed into being talked more about climate change. Was that a branding issue, if you will?
Well, the term global warming actually came into use as far back as the 1970s. So global warming slowly gained traction, but most people didn't hear the phrase until the late 80s, early 90s. But by that point, it was becoming clear that some of the bigger problems might not be the actual temperature rise, but the changes in precipitation. The fact that when it's dry, a warming climate will make it even drier, and where it's raining or snowing, the enhanced water vapor with the warmer temperatures can make it rain or snow harder. Because global warming doesn't really capture that piece of the whole puzzle, there is a general practice among scientists to start referring to it more generally as climate change.
So while the name has changed, the science hasn't.
I can summarize, I think, in a few sentences what we do know with a lot of certainty. First, human beings have caused the greenhouse gases to increase.
Right.
There's zero doubt about that.
Right.
Many, many lines of evidence, completely independent. We do know how greenhouse gases absorb infrared radiation from the Earth, which otherwise would go to space.
Right.
And keep it in the Earth system. We know this we know that with great accuracy. And then we also know that especially the CO2 change on Earth will be with us for a long, long time. We are committing the Earth and future generations to high CO2 for thousands of years. This is known.
Right.
Well, so climate change is a given.
But more than 1,000 miles away here at the University of Alabama in Huntsville, Dr. John Christie doesn't deny the climate is changing or even that man has something to do with it. But his overall take on the issue is decidedly different.
The evidence that we have shows it's a pretty small effect. And as someone who is a working stiff climate scientist, I'm one of the few people in the world who actually build these climate data sets from scratch. The evidence just does not support the notion of alarming climate change.
Christie has testified in front of Congress.
You can see here.
His research uses satellites to measure global temperatures, a method he helped develop. He believes computer modeling of climate change just can't take into account the complexities of the atmosphere.
Our science is just murky. And I think the real story is that the Earth is not changing anywhere near what was projected, and that we really have a lot more to learn about the system. We're just not very smart when it comes to all the things that interact with this incredibly complex but beautiful system that we see out there.
There's no doubt whatever is going on, it's affecting the people here in Barrow, Alaska. But Barrow, Alaska is not Raleigh, North Carolina. Coming up after the break, what we've learned here and what we need to know in the Tar Heel State.